Hey everybody, so I am making this video to help you get through the tutorial for similarity, proportion, and triangle proofs. So the big concept for this is how are similar triangles created within triangles? And the answer to that question is either by drawing parallel lines inside the triangle or by drawing an altitude in a right triangle. And I'll get to that example here in a bit. The other part to specifically pay attention to in this one, because I don't cover it that much in the other video, is the proofs. So when we get to the proof section, I'll show you what you should be looking for and stuff like that. So let's get right into it. So here's what I mean. So if you look at this, there's a big triangle and there's a little triangle on the inside. And notice that they give us A to D's dimensions, give us D to B's dimensions, they tell us B to E, but we don't know this distance right here. All right, now they tell you over here that this street is parallel to this street. Now, because they're parallel, that means that the big triangle is similar to the little triangle. And because they are similar, that means that these sides are getting cut proportionally. So what a proportion is it's two ratios that are equal, and a ratio can be written as a fraction. So in order to do a problem like this, you have to set up two ratios that are equal and then solve for x, or solve for a variable. Okay? Now the way that this works is there's a couple ways you can do it. All right, I always do it in one of two ways. I'm always either a left over right kind of person or a top over a bottom. Now the left over the right and the top over the bottom can be taken in two different ways. If I'm using this diagram right here, left and right are divided by the line drawn inside. Top and bottom are just the triangle itself. So top side, bottom side. All right, but you never want to cross the line to make your ratios. So I never want to make a ratio going this way. I never want to make a ratio going this way. I always want to either go across this way, or here and here. All right. So a top over bottom would be 8,375 over x equals 3,625 over 3,250. A left over a right would be 8,375 over 3,625, and x over 3,250. Now, the writing right here will explain kind of why you do that, but I'm giving you kind of the short version. And as you'll see on this next slide, okay, they eventually tell us that they're parallel and how to set it up, but it's not until slide 7 that actually give you the equation. So within this activity right here, you're going to be answering some questions based off a GeoGebra diagram, which looks like this. Now this one's pretty easy to use because you're not going to be doing too much. They tell you to show segment parallel to BC. So this segment is parallel to this segment over here. Now I can drag B around, I can drag C around, I can drag D around. So notice that that line is staying parallel to BC. So what they're going to ask you to do is to kind of find some dimension lengths. So remember, to find dimension lengths, I just click on this one here, go to distant length, A to D, D to B, A to E, and so on. So if these are similar and these lines are parallel, then the ratios I create should be equal. Now you're going to have to do a little bit of calculating on your own for that. But notice as I move these around, those lengths are changing, right? So if I did a left over right, then 13.6 over 11.48 should be equal to 11.6 over 9.79. That's a left over a right. If I was doing a top over a bottom, that would be a 13.6 over 11.6 equals 11.8 over 9.79. So as you go through this, there'll be some questions to answer. It's not too crazy, but just know they're going to ask you to find some distant lengths and stuff like that and ask you to compare the values. All right. Now here's that slide I was talking about where they're setting up our ratios. Now they did theirs a little bit differently than mine. Like I said, I usually go right over left and top over bottom. They're doing a bottom over top. Excuse me. Yeah, a bottom over top. So they're doing this amount over this amount equals this amount over this amount. And again, the reason that that's doable is because these lines are parallel. If these lines were not parallel, these equations would not work because this triangle here and this triangle here would not be similar. And they have to be similar in order for these to be proportional. Okay. And then here's an example of a problem that'll be good practice getting you ready for your test. So practicing your ratios. So make sure you spend some time on that. Next one. Sorry, I can't answer that phone. But this is a different variation. All right. So these lines are still parallel, which means that this triangle is similar to the big triangle right here. Okay. Ratios still apply. So notice they're doing AD over DB. They're doing like a top over a bottom. Top over bottom. They're doing more of like a right over left. Right over left. Right over left. Now you can go top over bottom, bottom over top, left over right, or right over left. The biggest thing is however you set up your first one, stay consistent with your second one, but never cross the line in the middle. So you would never do AD over EB. Okay? You can cross horizontally, like we're going over a dot, but you never go over the parallel line in the middle to make your ratios. And whatever you did for the first one, stay consistent with the second one. Now here's where you really got to take your time with this. All right, this is a really long proof. Normally you probably wouldn't do one this long in in-person geometry class, but drag them around. Okay. You can also view the diagram they're talking about by clicking on it right there. Okay, but see if you can get them matched up. See, like, that was wrong, that was wrong, that was wrong, etc. Okay, so play around with it and really pay attention to the reason for the statement. That is very important. Why is this, like, why does this word match with this equation over here? Okay. See, so you got to kind of just play around with it. So ABC with, I'm looking for the given. Given ABC with, so our given is we have parallel lines. There we go, boom. Okay. So if two parallel lines are cut by a transversal, then corresponding angles are congruent. So we're looking for two pair of angles being congruent. Boom, there we go. And you kind of just kind of go from there. All right, so again, paying attention why these statements match with the reasons. Okay. More information for you to go over. Next activity would be this guy right here. Now this one is talking about drawing in parallel lines. I think that's the right one. No, sorry, it's this one right here. 8.3. Which one is it? Which one? Here we go. I was on the right one. So it's asking us to measure these lengths. So what we would do, right, with our measuring tool, distance, A to D, D to B, and I always like to do A to B as well. Okay, A to C. And so what they're going to try to have us do is pick a point on AC and label it E that would make a parallel line right here with this. Okay, now their directions are kind of tough to follow. It says measure the length of AC, use coordinate algebra to locate point E such that AE to EC is equal to the ratio of AD to DB. All right, now I'm not going to have you do it that way because that way it'll take way too long. So instead, here's what I want you to do. I want you to click on the fourth to the right. So it says parallel line. So it says select a point and a parallel line. So I know I want a line that passes through D that's parallel to BC. So I'm going to click point D, and I'm going to click on line BC. Boom. There's my line. Okay. Then I want to plot a point right where those two are intersecting. All right. Now let's find that length. So if I did this correctly, if this line is parallel to this line, then the length of AD, if I did a left over right, AD over DB should be equal to AE over AC. All right. So you have to answer a few more questions in that one, but that should help you get through that activity pretty quickly without having to do too much of the math that's kind of unneeded, to be honest. All right. Moving on. See, there's our diagram. Looks just like my diagram right there. All right. Another proof. Take your time on it. Make sure you compare the statement to the reason. Statement to the reason. And then the last one, this one is where things can be a little bit tricky. So this is talking about drawing in what's called an altitude in a right triangle. So if you click on this right here, it's going to take you to this diagram here. Now the reason why this is tricky is because an altitude is perpendicular to a side and connects to an opposite vertex. So if I want to draw an altitude from side AC, that line would have to connect to point B, but it would also have to be perpendicular, aka form a right angle with AC. So if we go back to our directions, the first thing they ask us to do is to draw an altitude that connects the hypotenuse of the right triangle to the opposite side. So that looks like my right angle. So I want to draw a line perpendicular to this that connects to this. We're going to use this line drawing tool again. So perpendicular line. Select a point, select the line. Select my point, select my line. There we go. So that is the location of my perpendicular altitude. And then from there, if you notice, if you say click it, it shows it. It's exactly where I put it. All right. Now what this does, what an altitude does to a right triangle, is it creates three similar triangles. Triangle 1 is the original triangle. Triangle 2 is the medium-sized triangle. Triangle 3 is the smallest of the three. All three of those triangles are similar. All right? Because they all three are right triangles. So that is where you're going to do a little bit of angle measuring, a little bit of side distancing. Okay, so after you get those three triangles, as you can see, we have the three right here. You're going to find some angle measures and some distances. So let's find an angle. Go backwards. Remember, it's giving you the outside measure. Just go a different direction. Okay. Notice 53.13, 53.13. All right. So that is something to definitely take your time on to understand. Okay, because it's a little confusing. I explained this a little bit better in the video that's going to be attached on the same day. So please make sure you take your time. And then after this one, you're almost done. Okay. Please let me know if you guys have questions as you go. Have a good one.